Right, calculus. We pick up with our last part for 3.2, and that's finding the derivative of the functions using the derivative rule. So fortunately, you've seen some of this before, and what we are going to do, I'm going to do a basic example over here, and example D, I'm going to say that f of x is equal to x squared minus 3x. And we are going to find that derivative. And we'll do three others. The way we find that derivative is we take the limit as h goes to 0 of f of x plus h minus f of x all over h. This is our formal definition for the derivative. So we practice graphing derivatives. Now we're actually going to find the algebraic representation of the derivative. So f prime of x is equal to that. So f prime of x is equal to the limit as h goes to 0 of, we do f of x plus h. That means you take an x plus h and you plug it in for each x that you see here. And we get x plus h quantity squared minus 3 times x plus h. After that, we subtract the function. Well, the function is x squared minus 3x. So it'll be a minus x squared, and it'll be a plus 3x divided by h. And that is what we algebraically want to simplify. So I have f prime of x is equal to the limit as h goes to 0 of x squared, x plus h squared, I'll get a 2xh in the middle. I have an h squared minus 3x minus 3h minus x squared plus 3x all over h. Notice what happens. X squareds are gone. Negative 3x is gone. Everything else should have an h in it. So we have f prime of x is equal to the limit as h goes to 0 of 2xh plus h squared minus 3h divided by h. I can now divide the h out, and I get f prime of x is equal to the limit as h goes to 0 of 2x plus h minus 3. Allow the limit h go to 0. As that goes to 0, you get f prime of x is equal to 2x minus 3. Now, this is really interesting because if we were to look at our calculator at the original function said x squared minus 3x. And if we look at the graph, you can see that the function is going down, then it's 0, then it's going up. If we look at our derivative, 2x minus 3, you can see, sure enough, this is the derivative. See how it's sitting below the x-axis and the original function is going down? And then right there it crosses over the x-axis. That's where the function has a derivative of 0. And then you're above the x-axis and you can see that the function is on its way up. So 2x minus 3 is in fact the derivative. We're going to do that same thing here. Limit as h goes to 0 of, and again I'll write it up here, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So if we plug x plus h into this guy, we get the square root of 2 minus x will be a minus h minus the square root of 2 minus x all over h. So that's what we would like to do, and we need to get rid of that h in the denominator, okay? So we did a basic example here where we had a polynomial. Those work out pretty nice. What if we have a situation where we have radicals? Well, we're going to multiply by the conjugate, which is square root of 2 minus x minus h minus the square root of 2 minus x. Oh, that's a plus because it's the conjugate. When we do that, look at our new expression. We have the limit. H goes to 0 of 2 minus x minus h minus the 2 minus x over, we have our h times that whole thing over to the right there, this whole guy right there. Square root of 2 minus x minus h plus square root of 2 minus x. And you can see in this situation that the 2's cancel. The negative x and the positive x will cancel. Negative h over h will divide, and you get the limit as h goes to 0 of, h is divided, you get negative 1 on top, and on bottom, the square root of 2 minus x minus h plus the square root of 2 minus x. Allow h to go to 0. When h goes to 0, you can see that in the denominator, we have negative 1 over, those square roots are the same. So you get 2 roots of 2 minus x. And that is the derivative. That is the derivative. Let's look and see what happens if we have a rational function. Limit as h goes to 0 of, I plug in x plus h minus f of x all over h. Start by finding common denominators. Multiply top and bottom by x plus h minus 3. Multiply top and bottom by x minus 3. I have the limit as h goes to 0 of x squared minus 3x minus 3h plus xh, then a minus x squared minus xh plus 3x over my new denominator, which is x minus 3 times x plus h minus 3 over h over 1. What happens? The x squareds are gone. The 3x's are gone. The xh's, turns out that those are gone. And when you multiply by the reciprocal, a 1 over h, notice that you just end up with an h in the denominator here. And those h's will cancel. And I will get the limit as h goes to 0 of negative 3 over x minus 3 times x plus h minus 3. As you plug in 0, notice that the bottoms become the same, and we have negative 3 over x minus 3 quantity squared. That's f prime of x. Now, what I think is really cool in these situations is if you were to consider the graph, our original function is x over x minus 3. And if you look at the original graph, notice how the graph is discontinuous at 3. So my new graph should be discontinuous there too. Also notice how the derivative is always negative. As I trace this, as you continue to move to the right, you're always going down. You're always going down, which means the new derivative should always be below the x-axis. Always be below the x-axis. And so if I look at my derivative, it's negative 3 divided by parentheses x minus 3 quantity squared. I'm going to make that bold just so we can see the difference between the two. As I graph, notice how that sits below the x-axis the entire time, and again, it's discontinuous at 3, just like we supposed. So it does show the derivative. Great way to check your work. Okay, I'm trying to go over the ones that are a little bit more challenging because the easy ones, I think we've seen a lot of practice with those. If we haven't, I apologize. We'll take some more time in class to go over them. This last one, the limit as h goes to 0 of 2 over the root of x plus h minus 2 over the root of x all over h. This is difficult because it's a radical and a complex fraction. And in order to simplify this, I first need to make one fraction. So I will have the square root of x plus h, square root of x plus h, and here I'll go square root of x and the square root of x. And so now I have the limit as h goes to 0 of 2 roots of x minus 2 roots of x plus h over the root of x times the root of x plus h over h over 1. In order to simplify the complex fraction, we multiply by the reciprocal. So as you multiply by 1 over h, that's just going to draw an h to the denominator. Now, to get rid of those square roots, we multiply by the conjugate. Two times 2 is 4 minus 4x minus 4h when you distribute that through over h, roots of x plus h times this quantity in the bottom, 2 roots of x plus 2 roots of x plus h. That looks kind of ridiculous. I understand that. Again, we always have the limit as h goes to 0 until we plug that in. But notice what happens. The 4x's are gone, and the h divides off, leaving you with the limit as h goes to 0 of, you have negative 4 in the numerator, and in the denominator, we have the root of x times the root of x plus h times 2 roots of x plus 2 roots of x plus h. Now, this works out really, really nice. And that's what I'm trying to show you. A lot of these derivatives, they look bad for a while, but they do look really well later on. So that goes to 0, and that goes to 0. So we get negative 4 over the root of x times the root of x times 2 roots of x plus 2 roots of x. And look at that. That's negative 4 over, see, the root of x times the root of x, that's x. And then 2 roots of x plus 2 roots of x, that's 4 roots of x. The 4's cancel, and I get negative 1 over x roots of x, or negative 1 over x to the 3/2 power. Again, I love to look at the original function and its derivative and be able to compare them. I think that this is where a lot of the great learning happens. 2 divided by the root of x. So I can see that the graph is always headed down. So therefore, it's always negative. So it should always, the graph of this function should be below the x-axis. As I look at it, I go negative 1 divided by x raised to the parentheses 3/2 power. And when I do that, always sits below the x-axis. There we have it. All right. Some very tricky algebra there. Hopefully you can get the basic functions correct, and hopefully you have a shot at the more difficult ones. Good luck. Thanks for your hard work.